Hey everybody, and welcome back to my channel. I am Phil the IT guy, and today we're going to pick up from where we left off in episode 7. And I got to be honest with you about this episode. I planned to sit down and do a 20-minute walkthrough of our success and how great, how wonderful it all was. What actually happened though was I spent the better part of a week going down a rabbit hole. I was staring at ffmpeg logs, digging through GitHub issues that contradicted each other, going down Reddit threads. One thread had 3 different firmware versions that weren't matching the ones I had on my Reolink camera, and so they were out of date. At one point, I seriously thought I was just going to return the Reolink camera and buy a ring, which completely went against what I wanted to do. I did not buy the ring. What I did was work through the issues, and again, it took me that better part of a week. By the end of that week, though, I had something I think way more interesting than what I originally had planned. I have a fully working Frigate setup with a custom trained AI model that can tell the difference between a person just walking by and a person actually carrying a package and walking onto or yeeting it onto my porch. This is all running locally on my own hardware. No subscriptions required, no cloud, nothing depending on anybody else to keep it alive. And today's episode is going to be about what that journey looked like. All right. We left episode 7 with Frigate running in its LXC container on Proxmox with the MQT broker running and the Frigate integration set up in Home Assistant. First thing we need really is a way to see and interact with that camera in the dashboard, which is why we use the Frigate card. We talked about that a few episodes ago. The Frigate card lives in HACS. We set that up back in episode 4, so it's already there for us. We need to go and configure that and make sure it's showing what we need. Now I'm going to show you the card I've got and show you the settings I use to get there. So let's go ahead and go to my example dashboard. It's going to load up the card. It takes a minute for the first feed to synchronize. And now we have it. And you can see this is dramatically different than a standard card. We've got different controls on here. We have the standard camera view. We have the live view. We have the clips gallery, take a snapshots gallery. We can view the timeline of the recordings that are occurring. We can go full screen, and of course we have our audio and microphone controls here. So I can actually set this up so I can listen to the camera or talk back. And the first time you hit that talk back, it's going to refresh the screen. Again, takes a few seconds, but then you're able to use that freely from then on. So there we go. That's up, that's running. And it's way better than what we originally had. And this is far better than I had expected it to be. You can see running right on real time here. I'm going to show you the key settings we used for that. And I'm going to include this information in the description and a link, hopefully, to my blog where you'll be able to download these. But this is what we have. We have the type of camera, the camera entity I'm using, the live provider, the mode, which is WebRTC. We have to use that, definitely. And was the whole reason we had problems with Reolink. And then we have the different settings for the things we want to see on here. So there we go. That's the configuration for that part. And now that we have this working and we have the camera view set up, this is where the fun starts. So here we are. We've got the camera on the dashboard. The dashboard looks good, fully functional. It's working. Looks great, right? Wrong. This is not how it worked out for me. I left it overnight. I came back. I checked the ffmpeg logs, or the Frigate logs, I should say, and there are problems all over the place. ffmpeg is crashing. Stream reconnects. It crashes again. Reconnects every few minutes, like clockwork. The watchdog is restarting the process, so it looks fine on the surface. But I looked, and there's gaps. There's gaps all over my recordings. The microphone is working intermittently. The audio is not working. Everything's constantly falling over because the stream is unreliable. And with a little more research, another rabbit hole, turns out this is a known issue. Um, if I had researched more carefully, maybe I could have avoided it. But this is where I'm at, so I got to get through it. It's a known issue, apparently. Reolink's RTSP stream is notoriously unreliable. Um, and the Frigate community has known this for years. They've been dealing with it for years. The problem is that the advice has changed depending on the firmware version. which makes it genuinely confusing to troubleshoot. When I first hit this, I did what everybody does. I went to the Frigate docs. So the Frigate docs are in here. It's a long list of different cameras that are supported, and it tells you exactly what you're supposed to do. It gives you an example configuration that's supposed to work. So I tried doing this. Um, so the official Frigate docs for Reolink cameras recommend using the FLV format for this instead of RTSP, which to me makes sense because it's what they documented, so I imagine it's correct. Um, well, I switched to it, and for some people on some firmware versions, this works. Um, for me, not so much. So I went to GitHub. GitHub has multiple discussions on this. The first is saying, hey, the documentation is wrong. This thing doesn't work. Eventually, through that thread, um, somebody reported that updating to the latest firmware fixed the problem. Somebody says that the HPLV fixed their problem. Some of them are having both of them crash, like I am. The Frigate maintainer, he confirms the docs might be out of date. And in the middle of all this, someone posts another Reddit thread. Reolink Doorbell, docs out of date, no longer work. So I read in this one, useful information here. And then there's this one. This is the one that says the Reolink RTPSV intermittent failure due to scheduled maintenance reboot firmware issues. So this is, again, this gets me thinking more about the firmware. So this one's particularly useful. It turns out that some of the Reolink cameras, maybe mine, maybe not, they have a scheduled maintenance reboot baked into the firmware that drops the stream periodically. The stream, not the camera. Not a bug you can fix in the configuration. It's the camera itself forcibly disconnecting or cutting that feed, RTSP, FLV, whatever. For the D340W, specifically the camera I chose, the fix that finally worked for me came down to three things. First, a static IP, which we did initially at the beginning in episode 2. That's already done. Second, adjusting the go-to RTC configuration to handle the reconnections more gracefully. And third, and this is the one that actually made the difference, is switching the detection stream to use the substream via RTSP while keeping the main recording on the FLV. Splitting the roles between protocols based on what each one handles just works better on this specific firmware version that I'm using. I'll show you that exact config that established it. Bookmark this section if you're fighting the same battle I am, and definitely check the description for more information to get those config files. Okay, so the stream is stable, recordings are now clean, the Frigate card is displaying and working correctly. I should be done. But while I was going through all the logs and event clips, something started to bother me. And that was that I was seeing Frigate detecting people correctly at the door, which is great, but it didn't seem to have any concept of whether or not that person was the UPS driver or dropping off a package or just someone walking past on the sidewalk. So the Reolink D340W doesn't have built-in package detection. The white model does. I got the black model. There's no AI on the camera that knows what a cardboard box even is. And the default Coco model that Frigate ships with, this is what most people are running. Technically, it has a package class, but it's unreliable. It misses a lot, especially small boxes on the porch. And for my use case, knowing when a package has actually been left at the door, not just when a person walked past the door, I needed something better. That something better is Frigate Plus. Frigate Plus is the premium version of Frigate. So for $50 a year, you get access to a base model that's trained on images that were submitted by the entire Frigate community, which is significantly better than the default Coco model out of the box. But the real value here is that you get to train your own custom model on data you submit using your camera and your environment. The part I want to be really clear about, because I've seen some confusion around this online, if you want a one-time purchase option, you can simply cancel your subscription. It won't renew at the end of the year. Models that you trained are yours to keep and use forever under their terms of service. So subscribe, train your model, download it, and if you have to, cancel it. $50, one and done. Your model keeps running on your hardware forever. Now, we have a list of models that they support. There are 3 specific types of model offered in Frigate Plus: Mobile Det, which I'm not going to use, YOLO NAS, which I think is deprecated, and YOLO V9. For YOLO V9 models, the size is most similar to the current YOLO NAS models in terms of inference times and accuracy. And a good place to start is a 320 by 320 resolution model for YOLO 9S. For our setup, the Intel N100 with OpenVINO, YOLO 9S at 320 by 320 is the target. Good balance of speed and accuracy, well supported by the OpenVINO detector. And here we have the information about the Vino detector, models that are supported. All of this is in here at this link. This will be in the description as well. And next, this is how the training is actually done. Once you're logged into your Frigate Plus account and you've submitted some models, I've already trained up on 191 verified images of people, dogs, cars, packages, etc. to make my model better, and I got an optimized model which works amazingly well. I can continue to train that model and try to make it better. We'll see if I want to do that. But what happens is you look at the images that you've submitted, you look at them and you go, what is this? Is everything in here identified as it should be? Person, package, yes, absolutely. Verify that and save it. If I see anything in here that needs to be added to it, I'm going to add something. I'm going to label that object, and the model will then be trained to better recognize that particular object that I've done. So this is pretty simple. You just continue to do this. You do this with all of these images. Um, you submit them, and then at that point, you request a new model. You have to have at least 12 images for that. When you request a model, um, it's going to take up to 36 hours for that to appear. Once the model is ready for you, you just take the model number, and you'll see it here. You add those model numbers to your system, to your configuration YAML, and then you're able to use these going forward. It downloads everything. It sets all the settings related to the model detection, so you don't have to even do that at that point, which is really, really cool. So once you've added this number to your configuration, restart Frigate. When it comes back up, you're running on that new model. See how well it works. If you want to send more training material in, just start submitting those images and you're good to go. It's really simple to do all of this. Now, I'll show you how this is done on my system and how you submit these images. So I'm just going to go ahead and open my Frigate window here. And we're in my Frigate, and these are all little recording snippets that I have for review. But if I click this button, this is where I'm going to review with Frigate. I'm going to look at this and see what Frigate recognized. Now it wants to know, is this object a package? Well, technically, yes, it is. I want that type of thing to be recognized as a package. So we'll say yes. It gets submitted. Same thing. Is this a package? Yeah, why not? It's a package. What's next? Is this a package? Heck yeah, that's a package. You just do this a few times. You submit as many images as you want. Then you go to your Frigate Premium. You adjust those images here. Make sure everything is outlined and done. When you do your model, it's good. So it's pretty simple to use, and definitely improves the heck out of the model that you get from the out-of-box experience. All right, for the next part, I'm going to turn off this camera, and we're going to move to a different window. We're going to show you what it looks like in Frigate's debug view. And we're going to show our zones, bounding boxes, and that's all I really need. And I'm going to go downstairs, and I'm going to have my wife bring a package to the door. We're going to see what happens and watch that in real time.
A package was delivered at the front porch.
So there we go. Wife brought the package up. Frigate detects the person. Then, and this is the part that matters, it identifies the package. The alert fires in Home Assistant. Zone is confirmed. Label confirmed. Notification hits my phone. Person with package on porch detected. Alerted locally, privately. No ring, no nest, no monthly fee, just to watch my own front door. That whole week with the RTSP logs and the ffmpeg and the Reddit rabbit holes, worth it. So here's where the build stands now. We've got a dedicated mini PC running Proxmox, Frigate in an Frigate in an Frigate in an LXC container with OpenVINO GPU acceleration, a custom YOLO V9S model trained specifically for our camera on our porch, stable streams after a firmware aware config fix, push to talk on the dashboard, and AI detection that knows the difference between a person and a person with a package. All local, all private, all on hardware we own. Episode 9 is automations. We're going to look at everything I've installed. We're going to find ways to automate it. I'm going to do that, and then I'm going to show you the automations that we've built. Motion sensors, smart locks, Lutron switches, everything is going to start working together, and we're going to continue to build from there. Subscribe and hit the bell so you don't miss it. And if you went down the same Reolink RTSP rabbit hole and found a different fix, drop it in the comments. Genuinely, community knowledge is going to help out a lot for me and for anybody else that might be watching. I appreciate it. See you guys in episode 9.